In this lesson, we're going to answer the question, how do I find the surface area of a rectangular prism? So, surface area is basically area, but of a three-dimensional figure. Whenever you found area in Unit 2, you were just finding the area of a flat, two-dimensional figure. Well, now with three-dimensional figures, you have three dimensions. You have lengths, you have widths, you have heights, you have fronts, backs, lefts, rights, tops, bottoms. There's multiple sides to three-dimensional shapes, and we're going to be talking specifically about rectangular prisms right now. So if you take a look at number 8, you can see the net of the rectangular prism on the right, where actually it looks like a square prism because our base is a square. We could still call it a rectangular prism though. First, what we have to do is we have to fill in the missing dimensions. Well, do you notice how the squares are 5 by 5? That means wherever I see a square, I'm going to make sure that it has dimensions of 5 centimeters by 5 centimeters. Also, I know that this side of the rectangle is going to fold in with this side of the square, which means they must also be the same measurement. So this is 5 centimeters there as well. So that means all the edges, I should say the widths of the rectangles are 5 centimeters. The length of the rectangular prism, though, if you see here, is 8 centimeters. So all the lengths of the rectangles are going to be 8 centimeters. So I can use those measurements to find my surface area. I need to know the area of every single face. I need to know the area of all the different rectangles and the area of the two squares as well. Basically, what I want to do first is I want to find the area of a square base, just one of the square bases. If I know the area of one square base, well, then I obviously will know the area of the other square base because they're congruent. So if I find the area of just this square base, this looks like the front here, I'd have to do 5 times 5. 5 times 5 is going to give me 25. So I have 25 square centimeters for the square base. Next, I'm going to find the measurement of the rectangular faces that go all the way around. So this is my rectangular face here. And this one has a length of 8, and it has a width of 5, because as we learned earlier, the rectangles are 8 by 5. So I would have to do 8 times 5, which gives me 40 square centimeters. Now I'm ready to find the surface area. I know that there are 2 square bases. So I'm going to have to do 25 times 2 because there are 2 square bases. I could also do 25 plus 25. So that means 50 square centimeters is just for the 2 square bases. Next, I'm going to do the rectangular faces. There are 4 rectangular faces, and all 4 of them are congruent. All 4 of them are 8 by 5. So I'm going to take my 40 and I'm going to times it by 4 because 40 is the area of one face, but I've got 4 of those rectangular faces. So that's going to give me 160 square centimeters. Now I just have to put it all together. The square faces with the rectangular faces all together are going to give me an area of 210 squared centimeters. Okay, now let's look at number 9. Here you can see, again, we have the net of the rectangular prism on the right. This one's definitely got rectangles for its bases. And we have 3 different measurements. We have 7, we have 10, and we have 15. So this one's going to be a little bit harder. Let's see. I'm going to focus on the 7 here. Do you see how this rectangle right here is 7? I know that this rectangle over here is congruent to this one. So if the top of this one is 7, the top of that one is going to be 7. I also can see that if this, use a different color here, okay. I also can see that if this side is 7 right here, then I know that this side's going to be 7 because those are going to fold in and meet each other. So if this is 7 on this side, then I can see that over here would also be 7. And since this rectangle is the same as this rectangle, this would be 7. As far as this measurement right here, I'm going to look to see what the length of my rectangles are. So if you look back at the actual prism, here you can see I have a top width of 7, but what is the length? Well, it's going to be the same as what you see down here. If this is 15, then this must also be 15. So this must be 15 inches here. And let's see. That's going to be the same over here. 15 inches. Oops, there we go. Because again, the 7 is going to fold in with the 15. And of course, they don't really have anything here, but this side would be 10. Okay. Now we're ready to actually find the different measurements of the faces. So let's see, I'm going to erase this so we can get a fresh start here. I'm going to start with the top rectangular face. So the top rectangular face to me looks like this face right here. In order to find the area of the top face, I see I have a length of 15. Remember we said that if the bottom down here is 15, then the top is 15. And we have a width of 7. So the top rectangular face, I would have to do 7 times 15. And that's going to give me 105 square inches. Alright, that's the top. How about the side rectangular face? So now I'm looking at the side, maybe the left side right here. For the side rectangular face, it looks like I have a length of 7 or a length of 10 and a width of 7. It looks like 10 by 7 are the measurements. So what I would have to do 7 times 10, which would give me 70 square inches. And then we have the front rectangular face, which is this right here. I would have to do 10 times 15. Length and width are 10 and 15. And 10 times 15 is going to give me 150 square inches. So we've got the top, we've got one of the sides, we've got the front. Now we're ready to find the surface area. If you know the area of the top, don't you know the area of the bottom? Just take the top and times it by 2, because then you'll have the top and the bottom together. That's going to give you 210. If you have the left side, couldn't you times it by 2 and have the right side as well? 70 times 2 would be 140. And if you have the front rectangular face, can't you times that by 2 and have the back as well? Now you have 300 square inches. So 210 is for the top and bottom. 140 is for the left and the right. 300 is for the front and the back. So all you need to do now is add them all up. 300 plus 140 plus 210. And that's going to give you a total surface area of 650 square inches. So how can you find the surface area of any rectangular prism? Well, one way to go about this would be to find the area of each face and add them up. That will work with any prism. If you look at number 11, can you use that rectangular prism at the right to write an expression to show how you could find the surface area of any rectangular prism? Well, okay. Let's see. If I want to do A times B, to me that looks like the front. So A times B would give me the front. So I'll write AB. But actually, if I times that by 2, 2 times A times B, now I'll have the front and the back because I'm doubling it. And then I'm also going to have to add on, well, that's just the front and the back. How about the top and the bottom? Here's my bottom. A times C would give me the bottom. But if I times that by 2, then I'll have the top and the bottom. And how about, so I got top and bottom, I've got front and back, now I need left and right. So B times C would give me the right side, but if I times that by 2, then I'll also have the left side. So this could be the formula that I could use to find surface area of a rectangular prism. 2 times the length times the width, or 2 times A times B, which would give me the front and back. If I do 2 times A times C, or 2 times length and height maybe, that's going to give me the front, no, I said front and back, that would be the top and bottom, and then 2 times B times C would give me the left and the right. You actually have a formula just like that in your formula sheet. If you look where the arrow is pointing, you can see the formula for surface area is 2 times length times width plus 2 times length times height plus 2 times width times height. That's exactly what we just did on the last slide. You're doing 2 times everything because you're going to have 2 faces that are going to be congruent. So if you know the top, times it by 2, you'll have the bottom. If you know the left, times it by 2, you'll have the right. If you know the front, times it by 2, you'll have the back. So let's find the surface area of some of these prisms. We can use our formula to help us. Remember, surface area is equal to 2 times length times width plus 2 times length times height plus 2 times width times height. So let's see. Length times width. I'm thinking my length would be 10 and my width would be 6. So I'd have to do 2 times 10 times 6. That would give me the top and the bottom. And length and height would be, let's see, I'm going to say that 6 is the length, 20 is the height, so I would have to do 6 times 20, 2 times 6 times 20, and that's going to give me the front and the back, plus 2 times the width, which we'll say is 10, times the height, which is 20, so 2 times 10 times 20. So first I'm going to do multiplication because PEMDAS tells me to multiply first. I have to do 2 times 10 times 6. 2 times 10 is 20, 20 times 6 is 120. Centimeters. Okay, then I have to do 2 times 6 times 20. So let's see, that would be, 6 times 20 is 120, and times that by 2 would be 240. I'm running out of space here. And then 2 times 10 times 20, that would be 400. So now I've got, this looks like the top and the bottom, this looks like the front and back, this is the left and the right. Now I just have to add them up. 400 plus 240 plus 120 is going to give me a total surface area of 760 centimeters squared. Now if you don't like the formula, the other way to go is just to find the area of each face and then add them all up. So let's do the next one. Here we have, it looks like 2 square bases. I see a square here and a square here. So for my 2 squares, I would have to do 4 times 4, which is 16. But I'm going to times that by 2 because I definitely have 2 squares. 4 times 4 is just the area of 1 square. Times that by 2, and now I've got 32 square centimeters. Now for the rectangles, it's kind of nice when I have square bases because all the rectangles then are going to be the same. All the rectangles have, let's see here, all the rectangles have a width of 4 and a length of 12. So I would have to do 12 times 4, which gives me 48. That's the area of 1 rectangle. But since I have 4 rectangles, that would be 192 centimeters squared. So now I have to put them all together. The squares plus the 4 rectangles. 32 plus 192 is going to give me 224 centimeters squared. So you can decide how you want to do this. You can use the formula if you want, or just find the area of each face and put it all together. Doesn't matter to me. Alright, last problem. Rico is making a rectangular paper lantern that is 28 centimeters by 15 centimeters by 12 centimeters. He plans to cover the faces of the lantern with paper that comes in sheets that have an area of 9 square centimeters and cost 8 cents a sheet. How much will it cost to cover the 6 faces of this lantern? So it sounds like a surface area problem because we're going to be covering it in this, the different sheets of paper. And then we'd figure out the cost of the paper. So this is a multiple step problem. Let's see. First I'm going to find the surface area. I am going to use my formula. 2 times length times width plus 2 times length times height plus 2 times width times height. Now it says 28 centimeters by 15 centimeters by 12 centimeters. You're probably thinking, well, which one's the length? Which one's the width? Which one's the height? Honestly, it really doesn't matter in the formula, as long as each number shows up twice. Do you see how length is in there 2 times? Width is in there 2 times? Height is in there 2 times? But you're just changing the combos, length with the width. Oh, well then length with the height, width with the height. So it doesn't matter what number you put where. I might make 28 be the length and 15 be the height. And if I keep that going, 2 times 28, 15 for the width, 12 for the height. And let's see, I've done 28 times 15, I've done 28 times 12. The combination that I haven't done is 15 times 12. Do you see how each number shows up twice? Oops. Each number shows up twice, and it shows up in a different combination. 28 times 15, 28 times 12, 15 times 12. Now I'm ready to actually do the math. First I have to do the multiplication. Multiplication always comes first when I'm doing order of operations. Okay, so 2 times 28 times 15 is going to give me 840. Then I have to do 2 times 28 times 12, and that's going to give me 672. And then I'm going to do 2 times 15 times 12, which gives me 360. And now I'm ready to do the addition. 840 plus 672 plus the 360. Looks like I'm going to get a total area of 1,872 square centimeters. That's just the surface area. Now it says that the paper comes in sheets that have an area of 9 square centimeters. Well, this is 1,872 centimeters, or square centimeters. I have to figure out how many of those 9 square centimeter sheets I can fit in that 1,872 square centimeters. I have a division problem here. I am going to take the 1,872 square centimeters and divide that by the 9 square centimeters to see how many of those 9 square centimeter sheets fit inside the 1,872. So let's do some division. Divided by 9. And when I do 1,872 divided by 9, I get 849. That means that we're going to need, oh wait, I wonder if I did that wrong. 1,872 divided by 9. Oh, I did do that wrong. That is 208. My mistake. I knew that seemed a little off. That means I've got 208 sheets of paper that I need to cover my lantern. So if I have 208 sheets of paper, and each sheet of paper cost 8 cents, I am going to end up spending about $16.64, or I should say Rico will be spending $16.64 to cover this paper lantern. Okay, let's look at our takeaways. Surface areas, the total area of all the faces of a solid figure. You have 2 options. First, you can find the area of each face and then just add them all together. Or you could use the formula that we talked about below. And you can see, if you do length times width times it by 2, that's going to give you the top and the bottom. If you do 2 times length times height, that's going to give you the front and the back. If you do 2 times width times height, that's going to give you the right and left. But if you're not sure, which one's the length, which one's the width, which one's the height, just make sure each number shows up in your formula twice and with a different combination.